Now, one of the important domains, as usual, all the domains are very important. Now, then the communications and network also, it's one of the very important domain. And the first and foremost thing here is the OSI model. All the computer communication is based on this. So we will take a deeper look at this OSI model, what it is. It is a international standard for communication architecture. This is a reference model, open system interconnect. All the implementations are based on this model. For example, either you take a TCP/IP or any other protocol, it is based on this OSI model. There are 7 layers, and what is the basic purpose of this model is to make the computer to computer communication. The basic purpose is to communicate to the host to host communication using a network media. So let us see what are the different components of this model. Divided into 7 layers with each performing specific task, always numbered bottom to top. That is the bottommost layer is number 1 and the topmost layer is 7. Layers communicate only with the layers directly above or below. It cannot jump. Let us take a brief look at all these 7 layers. Layer 7, it is referenced by number, that is layer number or the name. The layer 7 is application layer, which describes the application layer describes the structure, interpretation and handling of information. It relies on all the underlying layers, the rest of the 6 layers. Number 6th layer, the layer below 6 is presentation, called the presentation layer, which describes the presentation of data such as ASCII, Unicode, etc. The layer below again is called is 5. It's called session layer, which establishes, manages and terminates the connections. Layer 4 is transport layer, which describes the data transfer between the application. Flow control, error detection and correction are the functions here. Layer 3, a network layer, describes the data transfer between the networks. Layer 2 is a data link layer called describes the data transfer between the machines. Layer 1 is the physical layer. Here actually it is bits and bytes, like electrical signals, cabling are concerned with this layer. How to remember? Because in the examination point of view, most of the questions they come either by referencing the name of the layer or sometimes by referencing the number. So it is better to remember the layers from 1 to 7. So the mnemonics for that is you can see here. It is processing data need to seem you have to from 7 to 1 if you want to read. All people seem to need data processing. So that is how you remember APSTNDP. The first letter corresponds to the layer name. All people seem to need data processing. Otherwise, if you are here is another mnemonic here. Please do not throw sausage pizza away. So application, presentation, session, transport, network, data link, and then physical. This is how one can remember. So the communication happens. Let us suppose this is on application 1. This is the application 2. Which is running on a host computer. This is one host, this is another. From this application layer, the data passes through the communication and then comes through all the channels, then go through the data transmission mission media. Then again it passes all the layers 1 to 7 and reaches the host on the other side. Now let us look into the details of each layer one by one. First we will take the physical layer. Physical layer is concerned with the cables, connectors, modems, hubs and NIC, that is network interface card. Physical characteristics of the network media. Physical layer determines the correct signal for devices being used and generates them. The electrical for copper or light for fiber optic media is the signals. The number 2 layer is the data link layer. The data link layer describes data transfer between machines, for instance by Ethernet. This layer prepares the packets it receives from the network layer to transmit to the network. Provides node-to-node data transfer, that is a reliable link between two directly connected nodes by detecting and correcting the errors that may occur in the physical layer. Subdivided into LLC and MAC sublayers. LLC is logical link control, MAC is media access control. LLC manages connection errors, that is a logical link control, which is it manages the connections, errors and flow control, and also controls bit sequencing. Media access control transmits and receives data using hardware address. Hardware address, this is an example of a hardware address. It looks like this. It is called MAC address, is also known as physical address. Now let us go to the next layer, which is the network layer. The network layer uses IP addressing to manage routing packets through the network. IP is an internet protocol, translates between IP addresses and MAC addresses. A translation happens from the IP address to the MAC address. What is addressing? An IP address is considered to be a logical address. We saw the MAC address as physical. This IP address is a logical name. And also fragmentation happens at this layer. What is the fragmentation? Will subdivide and also again rebuild if the size is greater than the allowed on the local network. We continue. What are the protocols in this layer? IGMP is Internet Group Management Protocol. IP V4 or V6, that is Internet Protocol. And the IPsec is the current latest the protocol, and other distance vector multicasting routing protocol. This is concerned with the protocols, this layer. And there is another two types of protocols, routing information protocols, which determines the direction and distance to any link, selects the route with the smallest number of hops. These are all very important functions of this communication. One has to send data from one computer to another. How do I get the smallest number and the least hops? How should I reach? So this is determined here in this protocol. May not be fastest path to the destination. Both, one is going faster, and another, the smallest path, least length. The other one, is the open shortest path first. This is shortest path here. Routing protocol based on the shortest path first, and results in smaller, more frequent updates, which make for more stable network. Smaller and frequent updates. Requires a lot of CPU and memory. That is one drawback. However, efficiency is high. Selects the lowest cost route. route, it depends. It is expensive. It is going to be traveling long distance. That is network consumption, bandwidth. The other protocols is UDP, that is user diagram protocol, connectionless, unreliable protocol, doesn't ensure transmissions are received without errors. The application has to do that. Application has to ensure that the transmission are received without any errors. Whereas TCP, that is transmission control protocol, connection oriented protocol, ensures error-free transmission. As segments are not arriving in sequence, the protocol reassembles the messages in the correct order. It is not necessary in the same order the packets will be received at the other end. The function, one of the function TCP does is to reassemble the received packets as per the sequence number. Each packet will be having a sequence number, so it is assembled based on that. What segments are received? When segments are received, an acknowledgement is sent. If not received, the segment has to be resent. So each segment, when it is received at the other end, the sender gets an acknowledgement. That's what it means. And finally, the very frequently used protocol TCP, a guaranteed communication session to set up using three-way handshake. How TCP/IP works? It works in three-way handshake. First, the client sends a SYN segment, a synchronization segment. It specifies the initial synchronization number. You can see here. First, SYN is sent. The server sends an acknowledgement, EXEK, and a SYN which acknowledges the client's SYN by responding with a synchronization number incremented by 1. Then this acknowledges the receipt of ACK and the request sync, that is SYN from the client. First SYN is sent, then SYN ACK, then ACK. That is the sequence. The client sends ACK to acknowledge the receipt of the SYN from the server, sending a suitable every time the synchronization number is sent. First SYN, then SYN ACK, then ICK, both the ends. That is the sequence. So now we go to the session layer, which is management of sessions between applications. Controls the dialogues, that is connections between computer, establishes, manages, and terminates the connections. Three modes are full duplex, half duplex, and simplex. Simplex is information can travel in only one direction, whereas half duplex host can exchange information, but one host at a time. Full duplex is both hosts exchange information simultaneously. Layer 5 protocol includes PAP, PPTP, and RPC. RPC is remote procedure call protocol. PPTP is point-to-point tunneling protocol. PAP is password authentication protocol. The standardization of the data presentation to the application is the function of this presentation layer. There are formats like data formats like EBCDIC, TIFF. TIFF is used for images like JPEG, MPEG, motion picture, formats. There are various. The function of this presentation is to the formatting. Details which deals with different character sets. That is what the examples here. That an application may use to present information by converting it to the standard code such as ASCII. ASCII is the commonly used, but these are all for EBCDIC is now it is not being used, whereas these formats are being used for images and motion picture. Complex activities include data conversion, character code translation, compression, encryption, and decryption. Everything happens in this layer. The application is the topmost layer. where the protocols used at this layer are DHCP, Dynamic Host Configuration Protocol, LDAP, Lightweight Directory Access Protocol, HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol, SMTP, Simple Mail Transfer Protocol. These the application portal to the network. The application use layer 7 services to transmit data. Now, how do we compare the TCP/IP with the OSI model, TCP/IP implementation? Here you can see the physical layer and the data link layer both are represented here by a network access layer. Though here the OSI model is 7 layers are there, TCP there is only 4, but it combines the functionality of the multiple layer into single. For example, the network access layer now is doing the function of data link layer and a physical layer. Similarly, the application layer here in TCP/IP combines the session layer, presentation layer and application layer functions of the OSI. Transport is same and then network link also same. It matches. Again the same comparison here. That is the TCP/IP reference how the implementation based on OSI model. The link, network, transport and application. 4 layer. Encapsulation of application data descending through the layers of TCP/IP model. Here you can see the pictorial representation, host A to host B communication through a router and a medium, network media. The data flows from application layer, then goes to transport, then internet link, then go to the Ethernet, then comes to the link internet through the router and then goes back to the application. We'll take a look at different network topologies. We will be covering all the topologies in this session. What are the different types of network topologies available? This is called bus topology. This is called tree topology, and ring, mesh, star. These are all the different types of network topologies. Let us see the advantages and disadvantages of these topologies. First, we take the bus topology. It's a straight. This bus topology is a central cable, actually one straight cable, which is called bus, which connect all the nodes. Here, in this case, this is the bus. Each node is connected into this, like this. So adding nodes is easy. You can add just another node like that. A node failure doesn't affect the entire network. Only that node, if something fails, this doesn't affect the rest of the nodes. But the bus failure, that is the central bus, if it fails, then the entire thing is failed. The entire nodes will fail. Then the tree topology, it is like this, one central cable similar to the bus, that is the central one, but the nodes connect to the branching cable of central bus. This is the branch, this connect to the central. Adding nodes, again here it is easy. Node failure doesn't affect the rest of the network here. A cable failure could leave the whole network inoperable, similar to the bus topology. Then comes the ring topology. As the name, it is a ring. Data is transmitted round the ring in one direction only, clockwise or anti-clockwise. Receive from upstream neighbor and transmit to the downstream neighbor. So it goes in one direction, either clockwise or anti-clockwise. As the ring uses tokens can predict wait time until the transmit. So the nodes have to wait until they get the tokens. Rings can be used as a LAN or a network. Simple rings have a single point failure. One node fails, the entire ring fails. All the nodes fail. Some rings, example fiber rings, that is FDDI, fiber optical, use dual rings for failover. If you use dual ring, it can fail over to the second one. Mesh, all nodes are connected to every other node in the network. Each one is connected to the other in the mesh. The mesh network provides high level of redundancy because each node is connected to the other. It is highly redundant, very expensive due to the high number of cables required. Partial mesh is multiple redundant path to other nodes. Then comes the star topology. All the nodes in the star are connected to a central device, here concentrator or a hub. Requires fewer cable than a full or partial mesh. Easy to deploy, nodes can easily be added or removed here also. Central connection device is a single point of failure. So if the central point fails, all the nodes cannot communicate. Now let us take a deeper look at some of the important networking protocols. One of the most important and the latest protocol is IPsec, IP security. Yes, a suite of protocols for communicating with IP with a mechanism for the main functionality or feature of this IP security is authentication and encryption. In standard IPsec, only hosts authenticate, whereas if the user needs to authenticate, then they have to use layer 2 tunneling protocol, L2TP. So IPsec interprets a change of address in the packet headers as an attack, so does not work well with the NAT. So NATed IPs, it will not work with the NATed IP addresses. So let us see what are the components of members of IPsec. First one is the AH, that is authentication header. The second one is ESP, that is encapsulating security payload. The authentication header provides the identity of the sender. When communication happens from one host to another, when the TCP/IP communication, as you know, or any, for that matter, any communication packet by packet, and the components of this IPsec, the first one is the authentication header, which is the identity of the sender. Whereas the ESP is the payload, encrypts the IP packets and ensures their integrity. So no change, nobody can meddle with that payload. It has got a header, payload and authentication. Header contains a packet sequence number, and payload includes the encrypted part of the packet. Authentication contains the hash of the packet. We know hash, what we saw that in the previous module. Hash is calculated when you want to ensure that there is no compromise to the integrity. Now security association. The security association will define the mechanisms used to communicate with the partner. This is another member of the IPsec. This covers one direction only. Second, SA required for two-way communication, which includes encryption algorithm, authentication algorithm, whether to use AH or ESP. Now, there are two modes in the IPsec, transport mode and tunnel mode. In the transport mode, the IP payload is protected. Only the IP payload is protected. In the tunneling mode, the IP payload and its IP header is also protected. The entire IP packets becomes a payload of a new packet and a header. You can see here below, down below, it is only in the transport mode, only the payload, IP payload is protected, whereas in the tunneling mode and the tunnel mode, IP payload as well as IP header are encrypted, protected. Internet key exchange. We again saw this during the symmetric key algorithm, symmetric key encryption when we learned about symmetric key encryption. The key exchange that happens here. Identify each other, establish a secure communication channel. First is to identify each other, whether known partner to whom really I want to send the message. The identity is that identity. Then establish a secure communication channel. The first phase, authenticate each other using either a secret key, shared secret key. The key exchange, it is out of band in the sense it should have been done already. Either using any method, either manually or whatever method, using a Diffie-Hellman algorithm. We again saw that, how to exchange key using Diffie-Hellman. So whenever a secret key is involved, exchanging is a problem. So it should have been, this is out of context here. We assume that the key has already been exchanged. Otherwise, if public key encryption is used, then no issue. Digital certificates exchanged, establish temporary SA secure tunnel for rest of the key exchange. In the phase 1, the authentication. On the phase 2, establish secure association using secure tunnel and temporary SA created in phase 1. Okay, now another point-to-point tunneling protocol. The weakness in point-to-point tunneling protocol is that it drives encryption key from user's password. It derives actually its encryption key from user's password. Violates a cryptographic principle of randomness. It doesn't use randomness. Can be a basis of a cryptography prone to cryptographic attacks. Also violates the recommendations for use of two-factor authentication for remote access. So these are all the disadvantages of PPTP protocol. And we will go to another protocol, layer 2 tunneling protocol. This is a hybrid of Cisco layer 2 forwarding L2F and Microsoft PPTP. A combination of both. Allows a user over a serial line using point-to-point protocol to connect over internet to remote network, and encapsulates point-to-point protocol packets into L2TP and forward to the remote server. Authenticates users to have access to remote network. It does not have encryption, but uses IPsec tunnel mode for confidentiality. Now another protocol which is widely used by the ISPs, which is called Radius protocol. Radius is remote authentication dial-in user service. Authentication protocol used in network environments such as ISPs, or where single sign-on for layer 3 network access is required. Uses simple username password encryption, and victim of number of cryptographic attacks. It is also prone to cryptographic attacks. Lacks integrity protection. Transmits only specific fields using encryption. This is about the Radius. And now we come to SNMP, that is Simple Network Management Protocol. Management server called the manager, and the client is called an agent. Manager and agent. SNMP allows the manager to get values from agent. That is, example is routing table or performance monitoring information. Now, this protocol is vulnerable to brute force attack. You know what brute force attack is? A brute force attack is keep on trying until until you break the password. That is brute force. SNMP version 2 did not support encryption, so password is faced as a clear text. SNMP version 3 has encryption for passwords. And now the Telnet is a remote access service, that is TCP/IP terminal emulation protocol. Like sitting at one host, you can log into the another remotely, and you can emulate the terminal of the other host. That is the terminal emulated telnet. Offers little security, not a very secured way, poses serious security risks, is limited to username password authentication. You use your user ID and password to get authenticated to get access to the other host. Do not offer, there is no encryption. Recommended, the telnet is not used over the internet. It is not recommended to use telnet over the internet. Maybe if a computer is within your internal network, so you can use telnet to log in to the remote computer internally, but using telnet over the internet is highly risky. Other services or login, remote login, remote shell, remote copy, using these services, remotely one can initiate a copy or initiate a shell that is sitting on one host or one computer. You can remote copy you can do on. These are all mostly used in the Unix systems. Nowadays this is not that popular. Just for the academic purpose we are going through this. This rlogin, rshell, and then RCP are used mostly on the Unix systems and X Windows system. Similarly, the virtual applications and desktops and virtual network terminal services. Telecommuting is very popular nowadays. Most of the people do telecommuting. Remote and virtual employee can be a convenient and a cost-effective method, telecommuting. Issues around employees who do not work at the company location. The issues are physical security, visitor security, and network control. What is the recommended control for this remote working, that is telecommuting? Strong VPN connection between teleworker and the organization is recommended. And full device encryption. This is for safety. Full device encryption and using a strong VPN connection for telecommuting. This is yet another interesting session. We talk about the attack phases here. There are 4 phases in any attack. Whenever an attacker plans to do an attack on IT systems or some such thing, he will be phase by phase he will be moving in. So though we are talking the attack phases with respect to network security, in general these attack phases are applicable to other domains also. So let's see what are the different phases. The first phase of this of an attacker is acquisition, that is discovery. He will try to find he will do study and then try to find some useful information, like he will do scanning, intelligence and surveillance gathering a number of for a number of potential targets. He chooses the target and gathers information about this target. That is the discovery. That is the first phase. How do you counter this attacker? What you can do is, as far as the network is concerned, one can use NAT. All the network administrators, most of the people are using NAT. NAT is a network address translation. The outsider will not know the real address. It is what they call is a NATed address. So the real address will be translated once required by the network. But the outsider will not know the actual address if you use NATed ID. The second one is limit access only on need to know basis. This principle is applicable everywhere. So limit the access on need to know basis only. Whatever is needed, only provide that much access, nothing more. So non-standard privileged usernames. Non-standard privileged usernames can be used. So if it is standard, then one would guess, for example, DBA means account name is user ID is DBA, then one can easily guess it is a DBA user ID. So instead, in a non-standard privileged names can be used. The aim always is to slow down the attacker, slow the attacker down. Will not provide any protection, but it is a delaying tactics. So by the time somebody could identify somebody some attacker is trying to get in. So it is always the strategy is to delay the attacker. So the first phase is the discovery or acquisition. The second phase is target analysis or enumeration. The attacker, he analyzes the data that he has gathered about the target that he wants to attack. So again, what are the countermeasures here? You have to perform vulnerability scan. By doing it, what are the known vulnerabilities, and it can be plugged in. Address all the vulnerabilities. Then regular patch management. If patch management is not done, then vulnerabilities are not plugged in. So regular patch management and configuration management. You can, by practicing good configuration management, one can avoid misconfigurations. Misconfiguration is one of the important vulnerability. So these are all the countermeasures one can take in order to slow down the attacker, or even you can stop the attacker. On the third phase, the attacker gains some form of access, like he gets some form of access into the target, which is called, this is also called vulnerability mapping. He has already gained some access. For example, what I would say is that if there are some user IDs that are not being used for a long time, this attacker might have, for example, I'm saying, he might have got into that particular account which is not being used. So he has got insight, but he don't know much. The next phase you will see what he will do after that. So how to avoid countermeasures for this? Again, privileges should be well managed. The profiles should be up to date, user profiles. Unused accounts should be always disabled or removed. And access logs, access should be logged and then monitored. It should be reviewed regularly for any suspicious activity. On social engineering and user awareness. Actually, social engineering is very simple but a very strong method deployed by the attackers. They make use of because the user is not aware, they make use of that and then try to get information. They are using social engineering techniques, like they just give a call and then act as if they are another employee, and they may be asking, where is those design documents stored? I thought that it was there in this, maybe. Like that they try to gather information. Change passwords. Another countermeasure is regularly changing passwords, using complex passwords. All the default passwords should be changed. Simple measures, but very effective. Again, aim is to slow down that attacker. Finally, he exploits the target, whatever appropriation. This phase is called the last final phase. The attacker will escalate the privilege using tools like what we were discussing, using any tool or even a social engineering technique or any other method. He escalates the privilege. For example, we saw that as an example, we saw that the attacker has gained access to the unused user ID, using which he has gained access. Now he will escalate the privilege, like for that, from that he will get some other user ID password which has got more privileges. What are the countermeasures? How do we avoid? Detect unusual activity in the log files. That is very important. Monitoring, a regular review of log files, and check for any unusual activity. Router, firewall and intrusion detection systems to be implemented. Host-based and network-based intrusion detection systems installed and kept updated. IDS and IPS, intrusion detection and intrusion prevention. And another important measure is user awareness. Make the user aware that such things may happen, and they should not be giving out the confidential or any information to unknown persons calling over phone or something like that. So consider whether the organization has necessary knowledge and skills. Here there is a suggestion that if the organization is very small and they cannot put full-time network administrator to take care of IDS, IPS and regular monitoring, that can be outsourced. So we saw 4 phases of any attack in the network perspective, but this is common for any other attack, not necessarily a network attack. Now let us take a look at network attacks. There are several types of attacks. Now in this session we will see different types of network attacks. What an intruder or an attacker, what types of attacks he will try to attempt. We will take a look at that. Okay, now to start with, we talk about the defense in depth. This defense in depth concept applies to even it's a general terminology that applies. Now we are seeing defense in depth with respect to the network security, but the same thing can be applied to physical security or application security or for that matter anything. The idea behind is at various levels you try to build security and make sure your network is protected at the various levels. So what are those levels? To start with, right from the policies, ISMS policy, and then the configuration. The ISMS policy should include all the the requirements, security requirements, baselining. What are the requirements, security requirements, and then you can. This is one layer, defense in depth. Different layers. Like the second layer would be configuration management, a proper configuration. Misconfiguration is always a vulnerability. So if one practices good configuration management practices, then we are building in defense, at every stage. Similarly, the configuration management practices, logging, monitoring, and then vulnerability management. At each of these levels, we are building security. That is what the defense in depth. Even in testing, based on all these factors like policies, configuration, change management, change management, logging, monitoring, vulnerability management, testing, reviewing, audits, backup, recovery, awareness and training. Not the last but not the least, awareness and training. So that is how one can implement the defense in depth. Let's see now some of the common attacks, network attacks. Okay, the first and foremost is the port scanning. Probing for TCP/IP services on a machine to identify potential vulnerability services or port numbers. This is to scan. An attacker would scan for vulnerabilities, open ports. How he does it, he uses the three-way handshake, TCP/IP handshake technique. Like he will send a SYN request. If response of SYN acknowledge, ACK is received, then the attacker knows it is an active port. Then attacker might send some other RST, that is reset, and so on. So the aim of the attacker is to explore, like see which port is open, and then slowly, what operating system it is running. So he knows the version of the. If he knows the version of the operating system, then he knows the vulnerabilities of that particular version. If it is not patched, then the attacker has got a good chance to intrude. Okay. So how do we avoid stealth mode on firewall blocks sending reset? So it should be configured. The firewall should be configured like that. So this is the first attack called port scanning. The attacker scans the port and then tries to identify the vulnerabilities. The second one is called FIN attack. This is again TCP/IP based three-way handshake using the three-way handshake. The attacker sends a FIN request to terminate communication. Closed ports reply with an reset RST. Open ports ignore the FIN. So the attacker now knows if he receives a RST, then the port is closed and there is no response, then it is open. And then again he will try to probe more. What operating system, what version of TCP/IP, what version of the OS, and what are the known vulnerabilities in this version of TCP/IP. So it goes on exploring, like we saw the discovery phase. The another attack is null scanning. That is, no flags are set on the initiating TCP packet. The attacker he sets no flags. On the next attack is XMS scanning, where he sets all the flags. All TCP flags are set. Why it is called XMS scanning? Because he is setting, that is lighting all the lights in the Christmas tree equivalent to that. Otherwise these scans work in the same manner as a spin scan, similar to spin scan. We saw port scan, FIN scan, null scan, and XMS scan. We now go to the TCP sequence number attack. We saw earlier when we studied about the OSI model, and we saw the implementation, how TCP/IP is implemented based on the OSI model. So that time we were talking about the sequence number. TCP packets have a sequence number to identify or correct the loss of packets. Each packet will have a sequence number. If a receipt is not confirmed, a packet will be retransmitted. That is how TCP/IP works. By eavesdropping. Eavesdropping is another terminology one would have to understand. Eavesdropping is going in between and then hearing. Eavesdropping is something like you are overhearing someone literally, but with respect to the network, it is you are trying to intrude and take some of the packets, intercepting and then taking the TCP/IP packet. By eavesdropping on traffic, a hacker can discover the sequence numbers, may be able to predict the next sequence number. It is easy to predict. If he gets one sequence number, then he should be able to predict the next number and insert fake packets into the data stream. Thus he can hijack. This is also called session hijacking. Another terminology, this is also called as a session hijacking. This is another type of attack. And now we come to the vulnerability scans. Can look at responding ports and applications on given server and determine the patch levels. That is what one of the main important aim of an attacker. An attacker always wants to know the target's operating system versions, more details, so that he can so that he knows, the known vulnerabilities are always published by the vendors, operating system vendor or the database vendor. They publish the known vulnerabilities. So the attacker can exploit those vulnerabilities. So that is why, always they will try to look for the patch levels, and then the server details. Running a vulnerability scan loads system and disrupt the operations. That's a problem. Like if someone, even ethical hacker runs a vulnerability scan, it is going to be disturbing the system. The performance is going to be slow. So one has to be careful when doing the vulnerability scan. And the next, after the vulnerability scan, the next part would be to perform a penetration test on the known vulnerabilities. See to and try to exploit the known identified vulnerabilities. And one has to be again, there is a caution that whenever a vulnerability scan or a penetration test is done, it is going to be risky and it could cause damage to the asset. So one has to be extremely careful when attempting such scans. The risk of pen test being tempted by a security weakness and value of the data stored. One has to be careful, otherwise there is a risk of losing the data or damaging the asset. And the next one in the network attack is a network tap. Network tap is a device that selectively copies data flowing through the network in real time for analysis and storage. It can be configured to acquire every piece of data, or can be selective, whatever is required. This can also be used for legal compliance for retaining records, this network tap. Like like an ethical hacker running pen test. If the same thing is done by the attacker, it is different, and whereas the ethical hacker doing a pen test is different. The purpose is different, both. Now coming back to the network tab, can be used to detect fraud and gather evidence. Can be used. May include voice, instant messaging, and other communication in addition to data. Not necessarily network data in the packets. Instead, this can also be used for intercepting and storing the voice information as well as the messaging, instant messaging information. Teardrop is another attack. Here in the pictorial form, it is very clear. This IP packet segments constructed so that when they are reconstructed, they have illegal lengths. See, normally the length here is 1500 bytes, but when it was reconstructed, it became 1900 bytes. So what happens? This may crash the system. If the target IP stack does not ensure fragment was within the appropriate boundaries, that is within these boundaries, then the host may crash or become unstable. This could be a form of a denial of service attack. We are going to see what is denial of service attack in the subsequent slides. This can be fixed with a vendor patch, this kind of an issue. Overlapping fragment attack. Some packet filters only inspect the first fragment. Firewalls are called packet filters, and that they do an inspection of packets or fragments. Some of the packet filters only inspect the first fragment. Sends a harmless first segment that satisfies the packet filter. An intruder can send a segment that can be satisfied by the packet filter, but it is a fake one. The subsequent packets override the first fragment with malicious data. That is the intention of the attacker. Have successfully bypassed the packet filter. Thus, he has successfully bypassed the packet filter. Because of the first fragment only it is inspecting, so there is no suspicion on the subsequent fragments. The solution for this TCP/IP this kind of fragment attack for TCP/IP stacks not allow fragments to overwrite each other. That is how this kind of a fragment attack can be taken care. When configuring TCP/IP, one should configure that the TCP/IP stacks not to allow, it should not allow fragments to be overwritten by each other. Another attack called as source routing exploitation. IP allows the sender to explicitly specify the path of a packet. See, normally it is not mentioned or specified. The path is not specified, but there is an option. IP allows the sender to explicitly specify the path of a packet where it should go. This can be abused, so a packet is forwarded between network interface on multi-homed computer, allowing attackers to access internal network. This what here multi-home is another terminology. One should understand what it is. Multi-homed is nothing but a computer having multiple NIC card, network interface card. So that will have two IP addresses if it has got two NIC cards. So the attacker, he abuses. So the packet is forwarded between the network interface and multi-homed computer, allowing attacker to access. He uses the other IP address of the NIC card. Normally, why multi-homed is this is for redundancy. If one NIC card fails, the other one should take over. So that is the purpose of the organization, but the attacker uses the other NIC to intrude the host. Source routing is specified by the sender in an IP datagram. Datagram. In the datagram is a packet, whereas the routing path is normally left to the router. Normally, the routing path is decided by the router. But now, because the user has an option to specify, he has specified this. What is the countermeasure? Disable source routing on host and block source routed packets. The user, this can be configurable parameter on TCP/IP. So if you set this, then one cannot specify the path of a packet, where it should go. The next attack is SMURF attack. Attacker broadcasts ICMP, that is echo request, what normally we call as ping. Ping is normally a command is issued to check whether the host is alive, whether it is responding. So here what happens is, this is broadcast. It is broadcast. This ping is broadcasted to whole network, like all the computers in the network will receive. The request is broadcast to every host on the network. Replies are sent to the victim whose address has been spoofed as a source. Spoofing is another keyword. The attacker spoofs the genuine address. And makes that as a victim, in the sense that is going to be affected. The victim is overwhelmed by the replies, causing denial of service attack. Denial of service is another attack, very common attack, denial of service and distributed denial of service. We will see that in the subsequent slides. The next attack is Fragile attack, similar to SMURF attack, but uses UDP instead of ICMP. Same thing, instead of issuing a ping command, ICMP echo request, here UDP broadcast a UDP packet with a spoofed source addressed to port 7 and 19 port number. Victim again, thinks that it is a genuine request. He is overwhelmed by the replies, causing denial of service attack. The next attack, finger, an identification service. This is no longer. This has become obsolete. This finger service, but it used to exist earlier. On earlier systems. Finger and identification service to obtain information about the last login time and whether it is currently logged in. Not very popular, that's what I was telling. It is no longer used as it has been subject to number of security exploits. For all practical purposes, finger has become obsolete. But how it was exploited is raises privacy and security concern and can easily be abused in social engineering attacks. Another popular is the NTP protocol, using the NTP protocol. Synchronize. Normally, one organizations use to separate server, time server to synchronize the clock time with several trusted time sources. If it is not done, the attacker, what he does is synchronizes computer clock in a network and prevent an attacker changing the attacker changes the timestamp. Thus, the information in the log, everything gets disturbed, like everything will be incorrect. That is the purpose of the attacker. Now we come to the denial of service attack. Denial of service attack is nothing but this is attacker attacks by consumption of computational resources, like such as bandwidth, disk space, CPU time, etc. He makes the host computer very busy, in the sense makes the computer to consume all the resources, so that the genuine user will not be allowed to work, will not be able to work. So that is how the genuine user is denial of service by an attacker, because already the attacker has engaged the CPU 100%, and then he has so now every request that goes will not be serviced. So there is a denial of service. This disruption of configuration information, such as source, such as routing information, disruption of state information, such as unsolicited resetting of TCP sessions. This gets disturbed, obstructing the communication media between the intended users and the victim. Victim is the target computer where this denial of service has occurred. So the genuine user, basically the genuine user will not be able to use the service. He is denial of service attack. And another type of denial of service is distributed denial of service. This is a network based. An attacker against a network by overwhelming its thought excessive traffic, or a traffic that has been created to confuse the network into shutting down or slowing down. The whole network is disturbed, in the sense the bandwidth chokes. So that is how the denial of distributed denial of service occurs. What are the countermeasures? Blocking the traffic from the attacker, but one should know if the attacker, then only you can block the traffic from the attacker who created unwanted request to make the network busy. And redundant network connections, that could be another method to counter this distributed denial of service. And then load balancing, careful filtering of on firewalls and router switches to check the unwanted traffic. Multiple layers of firewalls, again to filter unwanted packets. The basic difference between denial of service and distributed denial of service is that the distributed denial of service is network based, whereas The denial of service is host based. How much damage you think it would cause distributed denial of service? More than 2,000 a day is happening, the distributed denial of service. Cost is as little as $150 to purchase a DNL. It is available as a service now. One can purchase the tools required to tools, or even they can spend that much money, $150 to create a distributed denial of service. 1/3 of all the downtime is attributed to denial of service attack. Interesting fact. Okay, now we come to the distributed denial of service, DDoS we call, SYN flood. SYN, we know what is SYN. It is sent a TCP/IP three-way handshake. First, the SYN is sent. The distributed denial of service attack against the three-way handshake that establishes a three-way connection, establishes a TCP/IP connection. Flooding victim with SYN packets from different sources. So the victim is the compromised computer, which is flooded with a lot of SYN packets from different sources, not completing the virtual circuit with the final ACK packet. Because a lot of SYNs are coming and not able to acknowledge. So thus the denial of service happens. The countermeasure of blocking the sender no longer prevents the DDoS attack in this case. Screen Scraper is another attack, a program that can extract data from output on a display intended for a human. Like whatever is seen on the screen, this can be extracted. Screen Scraper can be used to capture image from a computer, from a user's computer. Capture can be by virus or malware. Captures even password and the PIN numbers. Can be used to capture passwords and PIN numbers. We saw earlier, okay, now SYN flood. SYN flood, a denial of service attack. Yeah, SYN flood is same, like multiple SYNs are sent to the host victim computer, and he is unable to acknowledge because he is overwhelmed by several flood of SYN packets. A denial of service attack against the three-way handshake that establishes a TCP/IP connection. Many new connections from a faked random IP address are opened very quickly, overloading the target. The aim of the attacker is to overload, make the CPU and the network, choke the network and make the CPU busy. Floods the victim with SYN packets. A lot of SYN packets goes to the victim, not completing the virtual circuit with the final ACK packet. Not able to complete the network communication. It is broken now because of this floods of SYN. Here the countermeasure include blocking the sender and increasing the size of the connection table. This is a configurable parameter in TCP/IP using which this can be countered. IP address spoofing. Spoofing is a common terminology. Address spoofing here. IP address spoofing and SYN ACK attack. A denial of service again. This is a denial of service attack against the TCP/IP connection, the three-way handshake that establishes TCP/IP connection. SYN requests are sent with spoofed address of non-existing host. SYN ACK to send to non-existing address. The patches are available to stop the system from falling when overwhelmed with incomplete handshakes. And because there is no such address exists because it was spoofed, a non-existent address. Email spoofing, we saw IP address spoofing earlier. Now this is email spoofing. The attacker will, give a fake ID. He will act as if it is a genuine ID. A very common SMTP authentication mechanism is inadequate. Email spoofing is simple actually. Spoofing email sender address by telnet command to port 25 of the mail server and issues SMTP commands. Used to hide the address of the sender in spam. Used to mislead the recipient via social engineering or phishing is another attack, phishing attack. This is very common, and you might have also received a lot of phishing mails. They might say that you click here and to update your bank account number or something like that. If you go and click on it, it will take you to a wrong site, and you will compromise your details, bank details or whatever, if you think that it is a genuine link. So when the spoofing attacks, many people have got cheated. A phishing attack, I mean. Similarly, this is similar to the phishing, the social engineering, like over the phone, ask for some details as if they are working with the same company and things like that. The most important countermeasure for this is educating the users. That is awareness to be created. Most effective protection is educate the recipients to ignore or delete implausible email. So one should be suspicious when they get such mails. Just using a blacklist of open email relays does not provide a secure, because new address gets created and new mails come. So we cannot block. You can block one address, but similarly several address gets created every day. Then the DNS spoofing. We saw email spoofing earlier, and before that we saw IP spoofing. Now DNS spoofing. To sort a domain name, DNS you must be DNS. One should be aware. Domain name server, DNS stands for. It stores all the the domain names and used for routing purpose. To sort a domain name query, the user's workstation will undertake series of queries through domain name server. The attacker poisons in the sense corrupts the DNS server cache by injecting fake records. This false information is in the infected server cache and will propagate to the other server cache. So thus an attacker has spoiled, he has poisoned the DNS cache by putting wrong information, incorrect information. This spreads to other servers. So thus causing the attack. The safeguard is to establish a DNS name server of your domain and monitor them very closely. Social engineering, now we are defining spoofed phishing mails gets users to click on a link to an address that is not one displayed. Can be used in conjunction with the DNS cache poisoning to send people fake sites. Yeah, basically social engineering is to make one to click on a wrong link, like as if it is a genuine. Here a diagrammatic representation how the DNS cache poisoning is happening. These are some of the common VLAN, that is virtual LAN, VLAN attacks. That is a MAC flooding attack. MAC, it is a physical address. And the another type of attack is interswitch link protocol tagging attack. Different types of VLAN attack. double encapsulated nested VLAN attack, ERP attacks, address resolution protocol, multicast brute force attack, and then spanning tree attack, random frame stress attack. These are all some of the names, common attacks on. The next topic we are going to cover in this session is SIEM, which is Security Information and Event Management. This is becoming increasingly popular. Many organizations have dedicated resources working on this particular SIEM. What an SIEM is? This is a system that gathers information from various sources, create a central information store, performs analysis and alerts issued. Basically, a lot of logs are there. A lot of we have IDS, IPS deployed in an organization, but each will generate different type of log files, different kind of information. But one cannot be specialist. Like one has to. The objective of the SIEM is to get alerts based on the live events. So better it can be done only using tool. Nowadays a lot of tools are also available for implementing SIEM. Why this is very complex and challenging, that is getting alerts at the right time, because many different systems and hardware are deployed in an organization. For example, maybe if an organization has got several servers, each will be of one different type. Like one could be an Unix and another could be an other one IBM. There are a lot of desktops, and each will generate its own log files. It will be in their own format. But how do I analyze different files in different format? And the sizes are also going to be very large, and it is not easy to understand these log files, because some of them could be in binary, some of them could be text. So how do I interpret from what has from the log file, like some untoward event has happened? It is not possible manually. So all this information has to be gathered from different types of systems and different types of equipments like routers or firewalls. All needs to be consolidated in a central database. And this needs to be protected against attempts to delete, change or purge, because like a timestamp attack, they would like to change the log because an attacker might want to safeguard himself, so he might try to change them. So these logs has to be protected, and this has to be analyzed in real time to reduce the damage from the attack. It has to be, if the attack is going to happen, and if you want to prevent it, you should analyze immediately and identify the threat. But if the analysis is going to take time, then by the time the attacker would have finished his attack and taken whatever he has wanted, like the data or whatever. So that is the purpose of the SIEM, is to have a single repository of all the information available from various devices and servers, and then analyze them and then give proper alerts at the right time. And it is most of the organizations, they have created a group for this SIEM, and a lot of tools being deployed to get alerts at the right time. Thus, we complete this SIEM. In this session, we will see a lot of network-related components and their how to secure them. Let us start with the security perimeter. The security perimeter, the first line of protection between untrusted and trusted networks. That is a security perimeter. In the sense, DMZ is a demilitarized zone. We will look at what is DMZ later, which is placed in an untrusted network. That is, trusted is internal. This is internal. Internal is a trusted network, whereas untrusted is an external network, which could be internet and things. So the security perimeter starts at the line between the trusted and untrusted network. What are the common devices that are being used in the network management? Firewalls, routers, proxies, IDS, that is IDS intrusion detection systems, etc. First line of defense, but should not be only line of defense. Yeah, this is to start with, the first line of defense. You keep firewalls, router filtering, proxies, IPS in the boundary. By segmenting and creating different domains of trust, we are creating additional boundaries that can be protected. That is partitioning the network. Within an organization, the network can be partitioned in order to manage it very well. Dual-homed host on firewall. Dual-homed host is has two NICs, that is network interface cards, one here and another here, each one on the separate network segment. When a host has got two NICs, we call that as dual-homed host. What is a bastion host? A gateway between a trusted and untrusted network. It stands in between the trusted and untrusted network. It gives limited access to untrusted hosts. Must authenticate to bastion host to gain access to the internal network. So one has to cross this host and come inside to the network. They has to authenticate themselves, any traffic that comes inside. The only node exposed to the public network, therefore, that is prone for attack. Common examples of these kinds of hosts are mail servers, domain name servers, web servers, file transfer protocol, FTP servers. Firewalls and routers may also be bastion host. Demilitarized zone, DMZ, very often we keep talking about DMZ. DMZ is an untrusted network that gives external hosts limited access to public resources, such as company website is kept on the demilitarized zone. No access to internal website or sensitive data. This is the DMZ. So if you are going to come inside the organization network, then through the firewall has to come, the traffic has to come. Now let us see some of the devices commonly used in networking. Modems, many organizations forbid modems on the network as they can provide easy access for intruders. So it can be easily it can be broken. So modems are being avoided. Multiplexers overlays multiple signals into one signal for transmission. And another one is dense wave division multiplexers combine optical signal. This is used for optical signals on one strand of optical fiber. Concentrators is another device, multiplex connected device into one signal to be transmitted on the network. Example, FDDI. Hubs were used to implement physical star topology. This is rarely used nowadays. This is obsolete and should be replaced as a legacy. Repeaters are used to re-amplify the signal so that they travel greater distance. Front-end processor sits between input and output devices and the main computer, reduces the overhead by servicing input-output on behalf of the main computer. The main computer can be dedicated to the processing of important applications, whereas the input-output request can be taken care by the front-end servers. Bridges, it's a layer 2 device. We saw the voice layers. In that voice layer 2, these bridges comes under layer 2. Join segments, filter traffic between segments based on media access control, MAC address, reducing unnecessary traffic and amplify signals to facilitate larger networks. Switches are similar to bridges but more sophisticated, multi-port devices that host connect to these switches. Only forward to specified MAC destination, greatly reducing the unnecessary traffic. Now let us take a look at the transmission media, the cables. Twisted pair is twisting reduces the interference. So unshielded twisted pair can be tapped and inexpensive. Shielded twisted pair more expensive, more secure, less flexible. Coaxial cables was used for computer networks, now mainly used for analog and other cable TV. Fiber optics, light pulses from an LED or laser can send down a glass cable stand. Since fiber relies on light, it is unaffected by electromagnetic and power-based noise. Makes it ideal for heavy industrial environments. Fiber optics. Now let us take a look at firewalls. Firewalls enforces administrative security policy by filtering traffic based on rules. When you configure a firewall, rules are set, and as per the rule it filters. Can be part of threat management appliances with other services such as proxies and intrusion prevention systems, IPS we call. Should be placed on boundaries between different trust domains. Here is one firewall and here is one firewall, here is one firewall. This is intranet, this is extranet, this is outer DMZ, inner DMZ. Firewalls are not only a security tool in modern network, they are the minimum security toolkit. They now are merely the first layer. It's a basic requirement. It has become a basic requirement, but more advanced protection devices are available. When packets are forwarded across a router, the packet header is read and routed. With a firewall, the packet is inspected and matched for flow, state, security, then routed. The basic functioning of a firewall is to filter based on the rule. Firewalls will not be effective out of box. Need to be defined correctly to prevent unauthorized access. The configuration. That is why misconfiguration is another big vulnerability. We keep on saying misconfiguration. Right configuration only can prevent unauthorized access. Need to be hardened. Hardened is another terminology we keep using. Hardening a device is by hardening a device, what we mean is that you make you plug in all the vulnerabilities and then make it hard for the intruder to come inside to attack. So that is the hardening part. To disable unnecessary service is one step in hardening. For example, a server can be hardened, a firewall can be hardened, even an application can be hardened. Hardened in the sense all the vulnerabilities are to be removed and make it tough for the intruder. So that way, must have patches installed. Firmware update and maintenance should be done regularly. That is the minimum requirement. Otherwise, all new patches being released by the vendors or most of them are security patches. So unless they are installed, the vulnerabilities will not be plugged. can be complex to administer and manage these firewalls. Monitor the log. Yeah, it generates terabytes of logs every day, but reading and then understanding, interpreting, and then alerting is going to be difficult. That is why we have to have tools to analyze the log. Alter the rules to meet the business requirement, apply patches. These are all the function of the administrator who administers the firewall. Outsourcing a firewall is now a significant and well established business. Filtering is based on the rule set, either by address or by service. There are two types of filtering: static and dynamic or stateful inspection. By address, check the source and destination address or both to determine if the traffic is allowed. Based on the address, you allow the traffic, the firewall rule. The next one is service, to filter out the services that are not allowed. Example may filter out finger is another service. The firewall can be configured to filter this service, to not to allow traffic of this service. Static filtering examines against static criteria, which is simple, and you cannot change rules temporarily to allow legitimate traffic. Sometimes legitimate traffic might be disallowed, so you cannot change dynamically. Whereas in dynamic filtering, examines the packet in the context of this session, can block malicious traffic that static filtering allows. More complex than the static filtering. Now NAT. We talked about the NAT, that is network address translation. Hides the entire network behind an IP address translated in a router or firewall, so remote connections only see the ISP's IP address and not the address scheme used by the company. Here in the figure you can see the actual IP address of this host is 192.1.1 and then 192.1.1.2, but from an outsider it will be a different one. It is 209.252.1.1 and then similarly it is translated address. That is PAT is port address translation. You can take an example here. These are all the hosts IP addresses 1, 2 and then 3. This is listed in this table PAT, that is PAT address translation. These are all the ports, and the NAT IP is this and the NAT port is this. This is used for translation, this table. An extension of NAT to translate all the addresses into one single IP address. All these into one single. Here if you see, all the same. Now proxy firewall facilitates the communication between trusted endpoints and untrusted endpoints. Circuit level proxy allows trusted host to communicate with the untrusted host, does not inspect traffic, low overhead, and does not identify malicious content. Different types of firewall. Application level proxy, application proxies allows trusted endpoint running a specific application to communicate with untrusted endpoint. Analyzes the traffic for common attacks and the protocol manipulation. Adds overhead to the scrutinies traffic. It's a overhead. Another type of proxy is web proxy. User authentication and logging used for user authentication and logging user traffic. Blocking inappropriate sites through URL inspection. Caching of popular websites, and then enforces applicable use policy. Every organization will have its own acceptable use policy. This policy can be enforced using the web proxy. Similarly, a company want to block certain sites, and that can be implemented using the web proxy. Personal firewalls protects users in a trust domain from other users in the same domain. Gives security in depth. Trusts no one. Designed to be easily installed. and configured by general user. Anyone can simply download and install. No comprehensive or flexible, but cover the basics. Stateful inspection and login are the functionalities of the personal firewall. Okay, now the common terminology: endpoint security. The endpoints are the users. End users are the biggest threat to any organization, because unless and otherwise they are aware of all the security related issues, they are vulnerable. They have access to the organization's most valued assets. Many will ignore and or shortcut corporate security policies. The normal tendency. Cloud may offer new ways to transport data beyond the reach of the monitoring system. Yeah, that is the biggest advantage as well as disadvantage. Sensitive data on user-held devices. The endpoints are often a most attractive target for malicious attacker. The end user should have least privilege. This is the principle, least privilege access principle. What is the need? As per the need, workstation should have workstations as a minimum should have up-to-date antivirus and malware software, properly configured and operational host-based firewall. It also should be hardened. Even the desktop should be hardened. Operating system should be patched and maintained regularly. Some of the steps to ensure security at the endpoint devices, like desktop, handheld devices, user-held devices. Threats to mobile devices and personal devices used as endpoints need additional defense. Consider using mobile device management system, like remote management, remote wipe capability, remote geolocate, remote update, and remote operations. These operations can be done remote. The user can be sitting somewhere in another country, and the administrator can do a remote wipe and do remote update of patches. And let's take a look at VPN, Virtual Private Network, in this session. The purpose of the virtual private network, that is VPN, is to have a dedicated network. Like it is practically, if you take the internet, it is not a dedicated one. If the traffic is going to go on the internet, then it is not safe and it is untrusted network. So how to make a untrusted network as a trusted network? That is the purpose of the VPN. It extends the private network across public network and enables users to send and receive data across the shared public network as if it is a private network. So take a look at this picture here. So this is the internet, and a branch office is here and another corporate office is here, let us suppose. And the users need to communicate securely, but they have to cross this internet. So for crossing this, they create a tunnel here. So the purpose of VPN in an encrypted tunnel between two hosts, this and this, that allows them to securely communicate over the insecure network. Internet is insecure. It is you cannot trust it. It is not a trusted network. So you build a tunnel which makes as if it is a private network. Here from the VPN router up to the tunnel, it is a private network, dedicated. Similarly, from the corporate office to the internet until here, it is a private network, so it is safe. Whereas this part, the internet part, you create a tunnel and make sure that the data traverses safely by creating a virtual tunnel. So where the application of VPN, most of the telecommuters, that is home, those who work from home, they use this VPN connection for safely communicating to their office. In this session, again, we will look into some of the core protocols and the terminologies related to the network security. And to start with, let us see what a unicast is. A unicast is communication from one host to the another. Here you can see it is from this host to this. Whereas broadcast is sent to everyone on the network or a sub network. Noisy and the problem is it would be noisy and inefficient, but very useful. Here you see from this to all the broadcast. And the multicast is only for a group. Deliver streams only to interested host. This. And to receive multicast, one has to join the multicast group. We are building some basics, and then finally we will use them towards the end of this presentation. Circuit switched. Circuit switched network establishes dedicated circuit between endpoints. A packet switch does not use a dedicated connection between endpoints. Instead, data is divided into packets and transmitted on a shared network. That is the difference between packet switched and circuit switched. And switched virtual circuits, it is torn after the connection is terminated, whereas permanent virtual circuits remains active even after connection is terminated. CSMA, Carrier Assurance Multiple Access Protocol, uses the absence and presence of a signal on the line as a permission to transmit. Only one device can transmit at a time. Devices compete for available bandwidth. Don't know when someone will transmit. These are all the features of the CSMA. CMA with collision avoidance and collision detection. Like collision avoidance, announce the intention to transmit with jamming signal, so no others don't transmit. Whereas the collision detection, if the collision occurs, messages retransmitted. What is polling? A method to avoid contention. A master device determines when other devices can send. Master will ask if they have anything to send. Then only they can send when asked. Token passing uses token in a ring network. A token passing around the ring, and the device can only send when it has a token. Used in token ring and FDDI, Fiber Distributed Data Interface. Ethernet, a methodology that supports different topology like bus, star, point-to-point topologies, but logical topology is bus. Logically, it is bus topology. Uses CSMA collision detection, low overhead, efficient use of the bandwidth. Too many collisions lead to poor throughput. Token ring, logically a ring network, but physically a star. Sends when it has the token. A legacy technology almost entirely replaced by Ethernet. Ethernet is more popular and very commonly used. Token ring is not that much. It's a legacy. FDDI is a fiber distributed data interface, a token passing architecture that uses two rings. Also a legacy technology replaced by ATM and MPLS, these two. Local area network services a small, such as home or office, small office or home. It services the needs of the local users. Workstations, servers, peripherals are connected as a star to this local area network. Ethernet is most popular LAN and which is very inexpensive and very flexible. LANs can be connected to other network. What are the diagnostics tools are ping, traceset and submask. Secure shell, we have seen this earlier also. SSH is a service that includes remote log-on, file transfer, and command execution. Remotely, one can log on to the another computer from the computer where they are already in. They can do remotely file transfers, command executions. Supports port forwarding, which redirects other protocols to an encrypted SSH tunnel. That is secured way. SSH tunnel allows the use of proxy servers, which most other VPNs doesn't. SOCKS, a popular circuit proxy server. User employs SOCKS to access a remote server. Initiates a connection to SOCKS proxy server, then proxy server accesses the remote server on behalf of the user. If the encryption is supported, the server acts as a VPN. SOCKS allows the use of proxy servers, which is most other VPNs don't. Now let us talk about the TLS, SSL and SSH we have already seen. TLS and SSL. SSL is secure circuit layer. TLS is transport layer security. These are all two protocols which uses encryption, a secure way of communication on the internet. This is another approach to remote access, leverages SSL and TLS to create a tunnel using a web browser. So you just need a web browser and you can use SSL and TLS and securely communicate. Currently does not support network-to-network tunnels. IPsec VPNs require a VPN installed and updated on every workstation, while an SSL VPN can just use any modern browser. That is the advantage of using SSL. You just need a browser, then you can do a secure communication. Only requires a web browser. The advantage of SSL over IPsec. Most networks permit outgoing HTTP. Can be operated through proxy server. Can restrict users' access. Does not have to have a VPN client installed and updated on every workstation. What is the disadvantage? And does not have a direct access to the network. Not the same as access from office. However, a direct access to network has security risks. This is simple to use and implement, whereas IPsec is more complex but more secure. Now let us take a look at the virtual LANs, VLAN. Virtual LAN is software based, it is not physical. Uses switches to create software based LAN segments. MPLS is another protocol which is a multi-protocol label switching, popular at the core of the carrier networks. This combines speed, quality of service and determinism of established switches, of switched technologies such as ATM and frame relay. This is the node A and this is the node B, and the packets pass through these tunnels. These are all tunnels. Message is routed to LSP. LSP is a label switched path, and LSR is label switched routers. This is LSR. These are label switched routers. The traffic moves from here to here.